Hello, if you're just joining here, I'm just a regular teenager that wants to get into software engineering, and I want to work at SpaceX eventually, and that obviously takes some time to build up. But so I just got some questions that I kind of want to pick your mind at. And the first one is what makes a piece of software, quote, good? And some options for that is it speed, reliability, or something else like entirely? So if it's really fast, if it's really reliable, or if it's kind of a combination of the two or something completely different. I just want to hear what you got to say. So it's something that you obviously need to know because you want to know like what to do whenever you want to make it good or whenever you just want it to work, that kind of thing. So if you want it to just work, for proto- oh, it's you. Okay. Um, Hi, Dad. Um, so maintainability, easy to extend with new features over time. That is good because you want to be able to expand upon it. You want to make it better over time. You don't want to make it the best at the very start because then you don't have something to make right after that. So you do want to start with something that works and does what it's supposed to do, but you need to be able to expand it and make it better over time. It's a good answer. All right, my second question is how do engineers know when to write new code from scratch versus using existing tools or libraries? And that's really important to know as well because you don't want to just start from scratch. You want to have something to build off of, or you do want to start from scratch because maybe the thing that you are designing doesn't exist, or it's very niche in the aspect where people don't really make it all the time. So, should you make something completely new, or should you use something that already exists that roughly matches what you want it to do? And then, should you just improve upon that or expand its reliability or something like that? Honestly, with me, I think it depends on what you're trying to make. If you want to, like, say, make a BOGO sword or something like I'm doing, you want to make it yourself because that kind of thing doesn't really exist right now. And if it does exist, it's not in the way that you want, or it's very just laggy or something like that. So the code that I had made, obviously I'm a teenager. I don't really know quite how to do all the things yet because I'm still growing and I'm still learning. And so I had it made for me. But it did teach me how to use something like AI to make it. And it did teach me how to basically be its boss and help it understand what it's supposed to do. But like, I had it make something that doesn't exist, and I made it exist. Like, this did not exist that long ago, and I made it exist. So that's really cool. And so 83 engineer said, some problems don't have software. Okay, some problems don't have software that does the job. Custom software gives you flexibility. That is true. And that's why, and that's because some software doesn't always do exactly what you want it to do. Sometimes you want it to do A and it does B, but you really want A, so you let it do A, right? You rewrite the code, you rewrite what it's supposed to do to make it do what you want it to do. And then, yeah, of course, custom software gives you the flexibility to do that. And whenever you actually do that, that makes it possible to do that A part instead of that B part. All right, question 3. Why do programmers spend so much time testing and debugging? Isn't writing code the hard part? So, to expand upon that, if you're a programmer, like I know 83 Engineer is, um, if you spend a lot of time testing and debugging, that saves you a lot of time afterward whenever you don't want it to be having issues. And honestly, writing code is kind of the easy part because you can control exactly what it does. Like if it has something that's going wrong, you can fix it with code. And if you make issues in your code, you can fix it, by fixing your code. So honestly, writing code isn't the harder part because it's all up to you. If you tell a computer to do something, that computer will do exactly what you say. And if you're wrong, then it will be wrong. Computers don't mess code up because it's doing exactly what it's said to do. Like if the code has an error in it, it will fail because that error is present. If you remove that error, then it'll go past it until another error, or it'll finish, right? So testing and debugging is honestly finding the harder parts and making sure that they do not fail, and that saves you a lot of time afterward. As you add new features, you can run all the existing tests to make sure you didn't break anything by adding a new feature. Yep, that is true. As you add new things, you want to make sure that nothing breaks that you already had working, and again, code can fix that kind of thing. So as you're adding new things, you want to make sure that those things that you're adding don't break future things that you could add. And of course, that's what makes it reliable. All right, question 4. What's more important in software, making it fast or making it easy to maintain? Can you have both? Now, from my point of view, I think you can have both because you do want it to be fast, right? You don't want it to be sluggish or slow and then it takes forever to get a result out. But you also want it to be correct, right? You want it to be easy to maintain because if you don't have those two components, well, you're either going to be fighting with a slow program, and you could also be fighting with something that's not really easy to keep up or easy to fix an issue when there is one that arises, which, as you all know, it will arise. And honestly, there might even be a trade-off to having both because, easy to maintain code can be slow, right? If you don't have a whole lot of stuff going on, or if you do have a whole lot of stuff going on, it can be slow. So I think a good balance between the two is important because having a balance in between is very important to be, fast and easy to maintain. One of the sayings that has always stuck with me: make it work, make it right, make it better. Sometimes scrappy software proves that your product is viable and worth making better over time. It's very true. So the first step of a progress, a program, you want it to just do exactly what you want, right? That doesn't have to be do exactly what you want and make it and have it do everything. You just want it to get the basic job done. So if you want a code to simulate a box jumping over another box, you just want it to do that. It doesn't have to be realistic. It doesn't have to be the perfect size box. You just want it to do what you want it to do at that moment and make sure it can do that. And then make it right means, well, okay, if you have this box jumping over another box, you want it to look right? You don't want it to just go up and slide. You want it to jump realistically, right? And then, of course, that leads into making it better. You can make it a whole lot more realistic, or you can make it in a realistic scene. It doesn't have to be grayscale. It could be in the middle of a forest, right? You can make it look really cool. And again, that goes back to the last question. If you get all that to work, you don't want to have the better things that you're making affect the things that already work. You don't want, say, if you're making a realistic scene, you don't want that scene to mess up something that you already have working. And sometimes scrappy software proves that your product is viable and worth making over time. Well, yes, because if you have something that's working, of course you want it to make it you want to make it better, right? Like the first iPhone, that was bare bones. It couldn't really do a whole lot. It had a basic camera, I think, maybe just one camera, and then it just did the basic thing that it was supposed to do: access the internet, be able to send messages, and I don't know, take photos, right? That's what it was supposed to do. But now they have made them better because one, it works. The first model worked. It wasn't the best, but it worked. And then they make it better, right? Like the 17 Pro Max. It literally can do about anything you ask for it to do. And that part of making it better is a very crucial part, because you don't want something that's just lame and can only do a few things. Like, you want to make it better because, well, I mean, one, everyone wants to make money, right? So if you make something that does a whole lot more, people will pay more for it, and people will want that thing. And if you want it, like if you make it better, that will increase that'll increase payout, that'll increase a whole lot of things down the road, and it'll make that product a whole lot better. Okay, question 5. How do programmers decide which programming language to use? Does it really matter, or is it just personal preference? Now, I know who you are, so I'll let you answer this one. But because I don't know, like, I know that some software languages have, um, they do certain things a lot better than others. They have a niche task that they do better. So I'm going to let you answer this one. But I know that some of them do things better than others, and you want to use it for that reason. So, wait for you. And to expand upon that, I think, yeah, that's fair. I think it depends on what your goal is. So let's say you want to build a rover that that is autonomous, it can go across your yard, it can do random things for you. You want that rover to use specific software that is that is made for that specific task. And that depends on, obviously, front end and back end, like AT3 said. But honestly, if you really want it to do what you want it to do, you want the very beginnings of it to already push you in that forward step. You don't want to, let me think of an example. You want to use the right tool for the job, right? You don't want to be hammering a nail in with like a battery, right? I mean, that's obviously not what you want to do, but you would want the hammer. And the hammer in that case, in this scenario, would be the right software, it would be the right language, and it'll be the right code to use. You don't want to use something that isn't really made for what you want to do. So you want to start from the very beginning with something that is already pushing you in that right process. So you want to go in the right direction from the very start. All right, question 6. Why do big software systems have multiple layers and components? Couldn't everything just be in one file? And my answer to that is, I feel like layers do make it easier to understand, because you're not pushing everything into one file, right? You're separating things based off of what they do, what they are supposed to help with, or what their goal is, right? You don't want to slam everything into one and then have to extract everything in the end. You want to be able to already separate them out. That way you can actually focus on one thing in this one or one thing in the other. Yeah, every class or file should have a single responsibility. It does one thing and does it well. That is true because, like I was saying, if you have separate files, you want each file to have its own role, its own responsibility, and it needs to do that one thing very well. And of course, in the end, you want them all to do the same goal very well as well. Get all the Lego pieces into place and you can build something out. Yes, that is true. Like if you had, let's say, bins of one Lego piece each, like each bin is made for that one Lego piece and you have a whole lot of bins. You don't have to be shuffling through a big bin that has everything. You can just pull out a bin and pick out that one piece that you need, right? And that one piece obviously won't change in that bin, so you know exactly what's going to be in it. So you don't have to be searching for the right thing. You can literally just pull it out and grab the right thing out. So that basically matches what I'm talking about. You want to have each file or folder, and you want it to do that thing very well and not have a whole lot of mixed components in them. Because if you have one small bug in that whole system and you have it isolated, you don't want to be searching through the big bin and trying to pull out that bug. You want to go to the specific folder or the specific area that you know it should be in and start deciphering that one area. You don't want to be doing the whole thing. All right, question 7. How do software engineers handle security? And can you ever make a program completely safe? So, in my mind, security is about reducing risk. And the best way to reduce risk is obviously to introduce safety into that, or security. You don't want to have a program that gets corrupt because of some file that corrupts it, right? You want to provide security to that file to block anything that is invalid or contaminated to actually get into that file and like mess it up, right? So like you protect sensitive stuff, you protect passwords or data or things that you don't really want to get wrong, right? You don't want to get those stuff taken away because of a simple error in your code. So you introduce security things into it, and that will inevitably like save your stuff. We have security scanners continuously scanning our software. There are also security standards that dictate best practices for doing certain things. That is good because obviously in your software you don't want things that don't match to be in there, right? You don't want something that could mess up everything, and it is good to have scanners that actually help with that. So I did not know that. That is new to me, but that is good because it makes sense. You don't want something in there that doesn't belong. So, and security standards make sense. Yeah, you don't want to store passwords in plain text because, I mean, if you open up a file, there it is, right? It's right there. You can just copy and paste it, right? You don't want that. You want it to be encrypted or scrambled, or you want it to be jarbled up to where it's not easy to just pick it out and steal it. So that does make sense. And obviously nothing's 100% safe. We've been fighting scammers for forever. And I mean, eventually there will probably be another scam that keeps happening or something else that happens that we don't even know about. But you just have to constantly know what to do in that scenario and know how to adapt and evolve. All right, question 8. What's the point of algorithms? Can't computers just figure it out themselves? Well, okay. This is almost similar to the bogus sort. If you give a computer a task and you don't give it anything else, it will try continuously and continuously, and it will also try things that obviously don't make sense, that are dumb, right? You don't want it to do that. algorithms give it ways or ideas that specifically match that one thing, and those algorithms help it be faster. It helps it be more efficient. You don't want it to be picking out random dumb stuff that don't make sense, right? You want it to be targeting the right stuff at the right time, because that will help it solve the issue. Because without them, it could last forever, like the bogus sword. Now, obviously, it's not going to last forever. It has a time where it will finish, but it's very simple for it to just make dumb actions or dumb decisions and keep them going forever and ever. Algorithms are the way. Okay, algorithm is the game plan for doing something repeatable and predictable and testable. Yep, I understand that, because obviously algorithms tell something like a computer what to do. You want it to be repeatable, you want it to be reliable, you want to know what's about to happen. So that algorithm is telling it what is about to happen and how to act correctly, essentially. Okay. Question 9. How do engineers know if their software can handle millions of users at once? Oh, I'm gonna let you guys answer this one, because I'm not exactly sure how that works based off of like front end or back end, like how it actually handles when, or like it handles that scenario, because that is obviously it's a very niche category, because that's one thing out of a whole lot of things that could happen. But like, what does what does someone do that makes a software reliable when millions of people are using it? Such as like YouTube. There's probably millions of people watching YouTube right now. What makes that reliable, and how do people plan for that? And by people, I mean engineers, because not everyone knows how to solve things. I'm gonna get a water while you answer. Load testing will confirm it to the best of our ability. Independently scalable components enable this. Okay, so what you mean by that is you simulate millions of people using your program or your software, and that helps with that, or independently scalable components enable this. So by that you mean if A can do this one thing, you make A be able to do a lot of things, or you make A be able to handle a lot of things. Scaling horizontally, spin up new instances of the application to handle more traffic. It's the best way to handle it. Okay, so scaling horizontally is vertical integration is like Tesla. They control every aspect of making a car. Horizontally is where you buy out other factors that I'm taking my Apris skill out of this. You take other companies that make what you do, and you take them in and you use it to your advantage. I think that's what that means. But spin up new instances of each application. That would be like opening my bogus sort a million times and making sure that they work on each one, essentially. If each instance can handle 5,000 users, then you spin up 100. Okay, that makes sense. So let's say this one instance can handle a few thousand people, right? To be able to test if it can handle millions of people, you just have to open up that instance that many times to reach a million, and then make sure that it works, work out any bugs, or work out anything that you may encounter, such as like bugs, of course, or issues that you may encounter. So that does make sense. You want to be able to test everything, and you want to make sure that it can handle that amount of people. And the way you do that is purely by making sure that it can, by simulating it, or simulating it. Okay. Question 10. Why do programmers use version control like Git? Isn't saving a file enough? So I'm gonna let you answer this one. I did use Git in the Bogo sort a lot because it had to get the libraries and be able to make keys, that kind of thing for the software. But I'm gonna let you answer that. So version control. That intentional changes over time, pull requests, make sure our code is reviewed when we merge the code after review, new version is created. Okay, so you have this one code and you get it reviewed, you get it tested, and then you get comments back, right? Whenever you make that comment and you change things, that is a new version, essentially. I think that's what that means. So if you change something, you make a new version of that, that would be a new version. We can deploy that new version to prod. If it breaks things, we can roll back to the last good version. Okay. So in that instance, if you have something that does work and you add something to it, you make it into production and you test it, you want it to work, obviously. But if something doesn't work and something breaks, you roll back to a version that doesn't break, that does work, and make that your final thing, right? And then behind that, you fix the thing that was not working, and then you put that into prod, and then do the same thing over again. It's just a loop. You want it to be able to do what you want, but do it really well. And you obviously want it to be scalable. You want it to do what it can at the best ability. So that does make sense. If you have something that does work and it doesn't, you roll it back, you implement something that does work really well, and then you fix the thing that wasn't working, and you put it back into prod, check if it works, and then that's your new version, if it does work. That is good. All right, question 11. What makes code clean versus messy? Is it just indentation or more than that? Let's look at the comments. Continuous delivery of software. A healthy team deploys software many times a week and incrementally moving the ball forward. Okay, that is good. Continuous delivery software. Yeah, so basically what I was saying, but you do it a lot of times every week. Your team does it a lot of time every week. And the end goal in the end is to have something that works and make it better. It's your end goal. If you can incrementally get up to that, you're doing well. That does make sense. Okay, back to the clean versus messy. Is it just indentation or is it more than that? So clean versus code, yeah. Clean code is architecturally beautiful, like beautiful bridge is nice to look at. That does make sense because obviously you want it to be easy to look at. You want to be able to easily spot messes, like mess ups in the code. You want to be able to spot bugs and easy to like fix those bugs. And Beautiful Code makes that really easy. Like if you have a whole bunch of comments explaining what that little chunk of code does, you isolate the problem, you find that in those comments, and then you fix that little block of code. And obviously, you still want it to work with what it was working with, so you don't want to change something and have something else change. And yeah, it makes sense. Humans read code, they should be able to understand what it does without being confused by it. Yes, that is very true. Comments help with that. Like if in, for instance, Java would, I think it's Java. In my old computer science class, we uses like hashtags for comments. Um, that was really helpful because that explains what that little chunk of code is, what it does, and it's not part of your code, right? It doesn't affect anything. So if anything, it's just very helpful. And you that allows you to isolate it, fix that little chunk, and move on. So obviously, clean code is good. You don't want messy code. And if you do have messy code, you still want to understand it. So you don't want to just have it spew out information and not be understandable. Code should be self-documenting and require minimal comments. Yeah, I get that because self-documenting, basically, it's simple. It does what it does. You need to be able to obviously understand it well with minimal comments as well, because I mean, comments can make it a little confusing as well, because if you separate it too much, then that's a lot of words on the page. You want it to just work, and you want it to be simple to read and all that. Naming is hard though, many people are terrible at it. Yeah, back in my old class, we had to name. It was pretty much a web development task or class, because we were using I think it was code.org, but we had to make apps essentially, and all those elements on the screen on the UI had names, of course, added to them in the code, and that obviously separated them from the regular things. But you want to name it in a way that you don't have to think about what that name means. It makes sense with the code, and it just doesn't make it complicated. Comments can become stale and out of sync with the code, creating confusion. No one maintains the comments or documentation as well as they should. Yeah, that makes sense, because if something is stale, it doesn't give you enough information, or it doesn't explain it well, that obviously is not what you want, and that causes confusion. You don't want confusion. You want it to be as straight, streamlined as possible. You want to be able to give it to someone that is in a different field than you, and they can roughly understand what it means, right? You don't want it to be so niche to your own ability, to where if you give it to someone that might be higher up or lower than you want them to understand it as well. You don't want it to just be you, and you want it to make sense to a wide variety of people. No one maintains the comments or documentation as well as they should. Yeah, I mean, if you can't write so many, like if you have this code, you can't write a million comments on it, right? That's just, you shouldn't. And it's kind of hard for that. You want it to be simple, and again, you want everyone to be able to understand it. So you want to make it good. You don't want to overcomplicate things. So all right, question 12. Why do software engineers split programs into functions or modules? Couldn't everything just be in one big block? So this kind of goes back to that one question where it was if you should have like code in different files or just one huge code. It's the same kind of question, and I'm going to say the same thing pretty much. Breaking up things is very crucial to helping understand the code, because if you break up things, you can isolate them based off of what they do, and they need to be able to do that one thing very well. And if they do that one thing really well, then you're going to be doing great, because that one thing is not that hard. It's not that complicated because it's one thing, right? It's like if you had a big file that did everything, that one big file is really hard to maintain, because you're I mean you've got a lot of things happening, right? Large methods are hard to test, many different forks in the road. Large methods are hard to maintain, hard to test, and generally a terrible idea. Yeah, if you don't want to go all in at once, because then you don't know what you changed quite as well. You don't know if you changed too many things or you didn't change enough, that kind of thing. If you change one variable and see what happens, then you know not to change that one variable. Or if you do, you make that one variable better or worse or whatever. You want to obviously make it better, of course, but you don't want to change too many things at once, because if you do, then you don't know what you changed. You don't know if it made it better or worse, or what made it better or worse, because one thing could have made it better or worse, but 10 other things could have made it worse, and you wouldn't know because you don't know which one thing made it better. So you want to change one thing and see what happens. Question 13. How do engineers decide what features to add and what to leave out? So, in my interpretation of this question, how to decide what to add or what to leave out. So, you want to start with something that works, right? You don't want to go all in and make it do everything at once from the start. So you want to start with something bare bones. You want to start with something that is very simple. It does the one task it's supposed to do, and it does that well. Then you add maybe something that users would want to use. Like, again, going back to the block question, if you had a block jumping in the woods onto another block, for instance, it's a weird scenario, but say that was the thing. You want to be able to make that one block, maybe do it more efficiently, or make it look more realistic. You want it to do the one thing very well. So, like, you want that one thing to do it well. And sorry, my brain just got off track, but our users should guide us. What do they want? Yeah, so if you take one code, you send it out to the community, they tell you what it should do or what you should add to it. You would usually want to add those things, because those are the people who are using your code. Those are the people who will, eventually invest in it or something in that way, and they want it to be you want it to be the best for them. So you do what they ask, or you do what they request, and that can make it better over time, because you're adapting to your clientele, you're adapting to what users want. All right, question 14. What's the difference between a good idea and a good implementation? Can a software project succeed with one but not the other? Okay, so you have a good idea, but your implementation of that idea isn't good, then you're not really doing yourself good, because you might have a good idea, but you might use it in a way that's not efficient or not great, and then you're just shooting yourself in the foot essentially because you had something that's good, but you used it in a way that wasn't great, and then you're just not doing it right. So I feel like obviously you need both because great implementation makes that great idea actually thrive. So, a good idea solves your real problem and ideally makes lots of money to fund the next things you want to do. Yep, that is true because obviously you want it to be good, you want it to work, you want it to be expanded upon, and that good idea, that's the basis of a good idea, right? You don't want it to be a bad idea because why would you? It's not great. You don't make money in that aspect. So that makes sense. I mean, a good idea isn't enough. You need the implementation to be good. All right, question 15. Why is debugging sometimes harder than writing code in the first place? Well, debugging is harder because you don't often see the bugs at the start because you're writing code, you're writing code, you're writing code, and then you encounter that issue, that bug. That bug could be like a random dot in your code, could be a random period, right? That could take you a lot longer than just writing the code to solve, right? And I mean, sometimes finding that issue or finding that bug is oftentimes the hardest part because you're being like a detective. You don't know what happened, or you do know what happened, but you don't know where it happened. So finding that bug is sometimes often the hardest part, and it's oftentimes harder than writing code because finding that issue is very tough sometimes because it could be just a random dot that you happen to leave in, but isolating the issue and solving for that one issue could lead you to that bug because you're going to the one spot where the issue is and you're fixing it, right? So, obviously, finding that one bug is sometimes harder than writing the code because it's not instant. You don't always know about it. All right, question 16. How do engineers balance speed, memory, and reliability in software? So, speed is obviously how fast the code works, or how fast you find the answer. So, if you write code to simulate like an asteroid hitting the Earth or something random like that, you want it to be fast because you don't want to be waiting forever for that answer. You want it to be quick and reliable and efficient. Memory and reliability. Memory, obviously, you don't want it to take up all your RAM. You don't want it to use up all your available like materials or supply. So, I mean, how do you balance speed, memory, and reliability? Reliability is pretty straightforward. I mean, you want it to work, but I think there's always kind of a trade-off because faster code could take up more memory, and faster code also might not be as reliable. So I feel like it's a certain use case that you would apply it in. Um, Faster code could be more efficient when you want something fast, but it could take up all that memory that you have, and it could be unreliable. So I feel like if you want something that is reliable, it could take longer to, I mean, it could take longer to find the answer, or it could take up more memory, that kind of thing. Question for me: what concrete steps are you going to take in the next 3 to 6 months to advance you towards your goal of becoming a software engineer? That's a good answer. That's a good question. The next 3 to 6 months. Well, as AT3 engineer is, he's well, okay. It's not that complicated to understand. He's my father, and he works for a contractor that works for Chick-fil-A, and he's a lead software engineer. And in the end of my, or like at the, yeah, at the end of my, in my career path, I would love to be a software engineer because I like what he does. I like solving problems, and that's all what that's essentially what engineering is. You solve problems to everyday tasks or problems, right? And you find answers. So my goal, I think, actually being in the workforce or being in that environment is really helpful. So I think watching what he does or going back and actually, like, again, yeah, just watching what he does, I think that's very valuable because if you don't see the things that are actually happening in the real world, you might oftentimes just believe that it's what you're taught in class or that kind of thing. So you do want to experience what it's really like and not just what some teacher are like is telling you what to think or telling you exactly what it is. You want to experience what it is in the real world. So I think being able to do that is very helpful towards progressing me to being a software engineer because if you take a computer science class, you might learn one thing, but in reality, it could be a whole different thing. And I feel like knowing what that whole different thing is very important because if you don't, then you don't know what the real world is like until you actually experience it. Okay, that was a good question. Thanks. Um, why do software projects fail even if the code is perfect? So, perfect code does exist because something does what it's supposed to do. Like, if you say, print hello world, right? It prints hello world, that's a perfect code because it does what it's supposed to do. Now, obviously, you can add stuff to it, but right in that instance, it's perfect. It's exactly what you told it to do, and there's no other thing that it could do, right? It's just print hello world. So, I mean, why do software projects fail even if it's perfect? Because sometimes the implementation of that code isn't great, or like software isn't like it's not just code, right? If yeah, for instance, if users don't like the software, it doesn't matter how beautiful and elegant the code is. So you you need to design something that works. It doesn't need to work perfectly, but it needs to work. Once you get that, you can adapt it. You can evolve it into something that does more or does a does something better, that kind of thing. So you want to start with something that does exactly what you need it to do, and then you can add on to it. So, I mean, you need to be able to adapt on that code. And if something fails in that perfect code, then I mean, you need to understand how to fix it after that. And once you do that, you need to actually be able to implement it well. And I mean, if if people don't like how it works, they just won't use it. So you need to be able to make sure it works. If you can't, then you're not doing anything for yourself. So I think that answers it mostly. All right, question 18. What's more important, learning a language or learning how to think like a programmer? So I feel like this, in a way, goes back to like if you're in a class versus the real world. If you learn exactly what it's like in a class, you learn pretty much exactly what's taught to you perfectly. You don't get that experience that you need to be able to take it into the real world because learning something in class isn't assuming that something breaks. It's not like assuming, it's pretty much assuming that you live in a perfect world and this thing that you're being taught always works, it's always true, that kind of thing. If you're in if you're in software engineering for a company, you experience things that you never really experienced in that class. And you want to be able to think like a programmer, as you need to be able to take something that you don't know about, and you want to be able to adapt. You want to be able to try and solve that issue without even fully knowing what's going on or how to solve it correctly. So I feel like thinking like a programmer is more important, because if you're thinking like a programmer, you're not thinking based off of like exactly what you're doing. You're thinking of how to solve that issue, and you're thinking of how to make it better, and just you want to be able to, where was I going with that? You want to be able to experience an issue and be able to understand it well and solve something that you don't always know how to solve. I mean, if you don't know how to solve something, you don't just give up. So, there you go. Thank you. I will be. And whoever the person is that's not my father, thank you for staying with this. Um, I'm not like I'm not in any way qualified to talk about this at all, but I'm thinking about how I would answer that, and I'm thinking like a programmer, like what I was just talking about. So yeah, there you go. All right, one more question, and then I think I'm gonna call it, because this is an hour long. But why do engineers use data structures like trees, graphs, and arrays? Can't a list? You know what? I'm not gonna do that one, because I don't know about that one yet. I mean, I kind of do. I know what a tree is. You have like your stem, and you have a whole lot of branches off of that, and those branches have branches, that kind of thing. But let me find another one that's not as complicated. Hmm. Okay. So, all right, this is a question. What's the difference between software that works and software that works well? So obviously the difference between that is something that works is pretty scrappy. It does exactly what you tell it to do, but it might have an error somewhere that doesn't make it exactly perfect. And something that works well, is something that is obviously working well, right? It's common sense. It does something pretty well or pretty good, and it doesn't have a whole lot of errors within it, and it does exactly what you need it to do correctly. So working software kind of just does the job, essentially, and that's what you would put out first. You want to give something that does work first out there, and you want to improve upon it to make it work well, right? You want to put something out there that does what you need it to do and nothing else, and then expand upon that to make it work well. So I think that answers that. Uh, I mean, software that works well is just, I mean, it's reliable, it's fast, it's easy for people to use, like your clients or your users, that kind of thing. So you want to take something that's pretty simple, make it better into something that works really well. So, first time I've kind of done this. Hope it's interesting. I don't know how it comes out across this, but I think it's quite fun to do. I like answering questions that I find online and that I generate. So I think it's pretty neat to do, and I hope you enjoyed this. AT4 Engineer, out.